ask for a question from this paper. So ABCD is a square. What does a square mean? It means all four sides are equal. Yeah. Now the second very interesting thing they tell us is BCE is an equilateral triangle. Okay. What's the point of that? They're basically telling that these three sides are exactly the same. Notice that one side of the square is the same as one side of the equilateral triangle. Okay. The point of this is to tell us that there's a potential that we can have an isosceles here because blue and green are the same. So let's carry on with the question. So we have equilateral, so 60, 60, 60. We have 90 degree here, right? Because it's a square. So this has to be 30. So now since A, B, A is an isosceles triangle, the answer is very easy to be found from basically 180 minus 30, where 30 comes from. Divide by 2. You should get 75 degrees. That is the answer. So there's nothing complicated about this, but always remember this, and this is a very, very, very standard trick, that the isosceles, when the equilateral shares a line with a square, it means that any side of the equilateral triangle, right, can form an isosceles with any side of the square. Then obviously, to actually formalize which one is the one that is the isosceles, you have to triangle, you have to see which one forms a triangle. Yeah, but it can be anyone. It could have well been this, and if the question decides to draw something like that, then it could have well been this as well. Next question. Okay, so this one, I normally avoid it, and I know for kids, right, whenever they see such questions on the paper, they always tell the parents they don't want to write, they don't want to draw. Okay, but now it's P6, it's fine. Your last chance to draw all this already. So go and do it. Now, first thing is rhombus A, B, C, D. We got A, B, and C already, right? So we need D. And roughly, we know the D is around this area. I don't know exactly where, but it's around that area. So, but how to make a rhombus? Rhombus, like all sides are always equal. So if you look at B to C, right, it's actually move 1 up and 3 to the right. From B to A is move 1 up and 3. So from A to the next point, you should go, same thing, 3 and up. This will be the point. You can double confirm by looking from C. From C, right, will be 1, 2, 3, and go. So the answer is definitely here. Now you ask me, what do you call this method of moving or this method of counting? There's nothing fanciful about it, but for those of us who play Chinese chess, right, and especially international chess, the way we move the ma piece is exactly the way, or the similar way to visualize for this. I know it's move 3 and move 1. It's slightly different, but this is roughly the concept you can apply to like how you move ma on the international chessboard. Second one, a little bit more effort, but let's see. So I'll erase this. Okay, we need another triangle that makes use of A and C, but it's 3 times bigger, right? Very simple. Now, if I were to ask you to measure this existing triangle, what will you naturally do? You will naturally do bases here, right? So this top small one is 2 times 1 is 1. This bottom guy, 2 times 3 divided by 2. So it's 3. Okay. So the small triangle, the area is 1 plus 3 equals 4. Yeah. Okay. because we need the new guy, the new triangle to be 3 times of it, the area of the new triangle will be 12. How to draw it without worrying too much? Let me show you. This is two squares right as the base. So to make something that's 3 times of this, we continue the 2 squares, but now we make it 3 times. And then how about the height? The height you can take any one because it's just 1 square up. Okay, so this is what I'll draw. And the same thing for downwards. Initially it was 3 square downwards, so now we continue the 3 square downwards. So you can see my new shape. Now, how to double confirm? Look at the width. My base is now 6, right? 6 times 1 over 2. This is 3. And then the bottom portion of it, 6 times 3 over 2. That will give me 9. So 9 plus 3 equals 12. So my suggested answer is to do this. Don't go and look for a new base or what. The base is given already. So the clue is normally based on the existing triangle, right? How are you going to find its area? And then using the concept of the base, let's try to keep it the same. Just extend the base. Because the height is the same. Point C and point A must be used. So I'll put E here. Next question, another square. Okay, so square reciprocal 90 degrees, right? So what we want to find? K, B, C. We're going to find this one. Okay, so because it's a square, right? We straight away can recognize that this is 90 degrees. Which means to say this portion here is 60. Similarly, since this is a square, recognize that this portion here is 90. So this portion here has to be 50. But you realize they actually overlapped a little bit. Okay. So there has to be something that has to go. So how would we handle this? We look around again and see what else can we remove from all those equations. So right now, the next thing we do, we look at the middle square. And see this is 90. This was 60, right? We established earlier. So that means this is 30. And since the below here is 50, it means the residue over here is 12. Yeah. So in this case, we will look at the middle square. This one. Yeah. Now let's zoom in what we had. This is 60, right? So because of the middle square, this will naturally be 30. Yeah. Now, below we saw a 50, right? 50 is like that. So to find the final answer, which is here, it will be 50 minus 30. So the answer is 20 degrees. Okay. Last one. Now, in my narration, I did advise that I would not be doing any of those very tough ratio and percentage questions, but I will be doing LCM questions. The reason why I'm doing LCM questions is because a lot of kids don't know how to identify them as LCM questions. And LCM questions are typically giveaways. Okay, so this is how to identify. He bought an equal number of keychain and trading cards. See, keychain always sell in packets of 4, right? And trading card always sell in packets of 3. Okay, so in order for him to buy the same, number, right, he had to be buying in the LCM of this, which means to say 3 and 4, the LCM, closest one is 12, right? So let me just draw it up. So what I'm drawing is 3 sets of 4 keychains each and 4 sets of 3 trading cards each. So then we evaluate, okay, exactly how much does this cost? 12 KC equals to 17 times 3, so it's $51. Missing quite. On the other side, one set is 3, right? So 3, we got 4 sets, right? So 12 trading cards equals to 4 times 8, $32. Yeah. So now, in order to make them to be same forever, we have to keep buying in combinations of 12 forever and ever until we hit whatever target we want to hit. But when we realize, right, every time we buy 12, the KC, right, will be $19 more. See? Because it's $51 and the other one is $32. So if one set of KC is $19 more, then if I buy 2 sets of keychain, 2 sets means 12 plus 12, right? Equals to 100 and this. Then of course the other side will be 12 and 12 will be $64. So the difference will now be $36. So I can keep repeating this until we hit $76 on the middle here. Or I can just simply say a set of 12 give us a difference of 19. So if I want a difference of 76, how many sets do I need? I take 76 divided by 19, I get with 4 sets. So the answer is I need 4 sets of each thing. And these 4 sets is not 4 sets of the initial combination. It's 4 sets of these blocks that I have drawn. Which means to say, how many keychain did he buy? He need to buy 4 sets of my combination of 12. So the answer is 48 keychains, or 48 trading cards for the matter, because it should be the same.